so let's finally check out an example where we calculate out some percentiles and quartiles. Well, one quartile and one percentile. Now recall from the last one, we calculate the index of the value that represents the first quartile and the 80th percentile. So the first thing I'm going to do is I'm just going to write down the index of each of these values. Once again, we're still using that same example where it's just the number of defects over 10 different days in some production process. So of course the index of the first value would be 1, 2, 3, 4, 5, and so on. So I just wrote down the index or the position of each number when it's arranged in ascending order. Alright, so we want to find the number of defects which would represent the first quartile and then second the 80th percentile. So of course the first quartile is the 25th percentile, so let's go ahead and do that. First thing we want to do is calculate out the value of the index. So the index I is equal to the percentile of interest, P, divided by 100, multiplied by the number of values that we have. So in this situation, the first quartile is what we're looking for, so the value of P is going to be 25. So it's going to be 25 divided by 100, and then multiplied by n. N is the number of values, and we have 10 different values, so multiply by 10. And that's going to come out to be 2.5. So we're in that first situation now where when our calculated our calculated index is not an integer. So when we get an integer, or when we get a non-integer or a decimal, what we do is we just round up. So the index So the index of the value that represents the first quartile or the 25th percentile is that rounded up, or 3. So now it's really easy. All we do is we just look, index of 3, that value associated with that is 1 defect. So the answer is just 1 defect. All right, next, let's go ahead and go on to that second one. Now we want to calculate out the number of defects that would represent the 80th percentile. So again, first thing we want to do is calculate out the index. So that's going to be equal to our percentile of interest, which in this case is 80, divided by 100. And of course, we still have 10 different data values. And that comes out to be 8. Now, because we got an index value that is a whole number, now what we have to do is to figure out the number of defects that represents this 80th percentile. We have to take the average of the value that is in the 8th position plus the value that is in the 9th position, or 8 plus 1, 9. So the value in the 8th position is 2 defects, plus the value in the 9th position is 3, and of course the average is just divided by 2, so that's going to be 5 over 2, or 2.5. So the answer is just 2.5 defects for that.